Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about isometric projections. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now here we have been provided with the orthographic projections of a solid in which the front view, the top view and the left hand side view of the solid they have been provided to us, and using the information available in the orthographic projections we are required to draw the isometric projections of the solid in which the front face, the top face and the left hand side face of the solid will be combined in a single 3D view. So in order to draw the isometric projections we need to evaluate the dimensions of the front face, top face and the side face of the solid. So when we look at the solid from the front side, we observe that the length of the solid happens to be 36 millimeter and the height of the solid it is also 36 millimeter. So the front face dimensions will be a square of 36 millimeter edge over here. Similarly, looking from the top, so once we observe the solid from the top, we observe that the length of the solid it is again equal to 36, while the width of the solid it is available with us from the left hand side view. So this width will also be equal to 36 millimeter. So once again the top face of the solid will be a square measuring edge equal to 36 millimeter. Similarly, in the left side view we have got the width of the solid equal to 36 millimeter and the height of the solid it is equal to 36 millimeter. So the side face it is also a square having an edge equal to 36 millimeter. Now since in this orthographic projection the left hand side view has been drawn on the right hand side, so we are going to observe the solid from the left side. So this is the left side view. So the left side view will be obtained in the XY plane over there. That is, along the XY plane we are going to have the square face of the left hand face of this particular solid, where along the x-axis the 36 millimeter edge will be marked and along the y-axis also 36 millimeter edge, that is the height, will be marked over here. So this is the width of the solid, that is along the x-axis the width of the solid has been marked and along the y-axis the height of the solid equal to 36 millimeter has been marked. Now if we have drawn the left side over here, so the front view will be drawn along the YZ plane. So this is the Y plane and this is the Z axis. So along the YZ plane we are going to draw the front view. So the length of the solid will be drawn along the Z axis and the height of the solid will be plotted along the Y axis. So whereas the top face or the bottom face it will be drawn along the XZ plane. So along the XZ plane we are going to draw the top face or the bottom face of this particular solid. Now let us first of all discuss about the geometric construction of the solid. So as we observe this solid from the front, so we observe that there is a web which is a flat web at the bottom, and this flat web is having dimensions. Height it is equal to 12 millimeter and the length it is equal to 36 millimeter. So there is a horizontal web over here which is measuring 36 millimeter length and 12 millimeter height over there, and then there is a central vertical web over here which is extending from the top of this bottom web which is horizontal. So this vertical web it is lying at the center and it is having the width equal to 12 millimeter. So from the front side we are able to see this vertical web in the front view. Similarly, when we observe the solid from the top, so we find that this was a flat surface at the top over here in the front view. So when we observe the solid from the top view, we see that there is this web which is having the width over here, it is equal to 12 millimeter and the length of this web, horizontal web at the top face, this is equal to 36 millimeter. and then once again at the center we have got a flat web at the top face of the solid. This is the flat web at the top face. How do we say this is flat web at the top face? Because this surface happens to be continuous. So this continuity of the surface indicates that this is a flat web which is lying at the top face of the solid. And then these are two inclined webs. How did I decide that these are two inclined webs? On the sides, on the either side of this vertical web over here. So this is a vertical web. This is the horizontal face of this vertical web which will be lying at the top over here. So this is vertical web as it appears to us from the front view. This is horizontal web which is lying at the top face. So we can conclude over here that at the center there will be a vertical web which will be running across the entire width of the solid over here. Now there are two inclined webs over here on the either side of this vertical web. How did we decide that these are two inclined webs? Because over here from the side view we can check. From the side view we have got this inclined web projection appearing in the left side view. So this web starts at a distance of 12 millimeter from the back. So please check, this is 12 millimeter from the back. It means from this portion, similarly from this portion, we are going to move down towards the top of this particular face over here, top face of this horizontal web that we discussed right in the beginning. So it will start from this point and it will be ending up at the top face over here. So now our web will be starting from here over here and it will be ending over here at this particular position. So this way the central web, it is vertical, whereas the side webs, they will be starting from this position and they will be ending up at this position, and this position will be lying over here in the front view. So they'll start from here in an inclined way and they will be ending up at the top surface of this horizontal web. So this is the basic discussion regarding the geometry of this object. Now let us start working out the isometric projections. In order to draw the isometric projections, we are required to draw the isometric scale, and through this isometric scale, all the true edges, whatever true lengths of the different edges they are available with us in the orthographic projections, all these true dimensions, they will be converted into the isometric length projections over here. And once the corresponding isometric length projections they have been obtained using this isometric scale, we can start with the construction of the isometric projections of this particular solid. Now in order to draw the isometric projections, first of all we are going to draw the horizontal datum line. So this is our ground line or the horizontal datum line, and once we draw this horizontal datum line, we are going to mark the origin point O over here, and then from this point origin we are going to move towards the left hand side, and the isometric x-axis will be drawn at an angle of 30 degree with respect to the ground. Similarly, from this origin point, as we move along the right hand side at an angle of 30 degree, we are going to obtain the isometric z-axis over here. And if we move vertically from this origin point, the height of the solid, it will be located along the y-axis. Now we know that the dimensions which are obtained along the front face, they are equal to length equal to 36 millimeter, and the height, it is also equal to 36 millimeter. So we have drawn the length equal to 36 and the height also equal to 36. So we have to complete this face. So another isometric edge parallel to the y-axis measuring 36 millimeter has been drawn, and another isometric edge which is parallel to the z-axis which will be measuring 36 millimeter length has been drawn. So this completes our front view face of this particular solid. Now let us proceed with construction of left hand side view face of the solid. So we know that the width of the solid, it is also equal to 36. This is the width of the solid. So So the width of the solid happens to be 36 millimeter. And once we have drawn this width, draw the height of the solid equal to 36 millimeter. This we have already drawn along the y-axis. So between the xy plane, we are going to obtain this left hand side view. This is the left hand side view of this particular solid. And now another isometric line we are going to draw parallel to the x-axis, measuring 36 millimeter, and another isometric vertical isometric line we are going to draw parallel to the y-axis. Again, this will be measuring 36 millimeter. So this will complete our left side view face of the solid. Now let us complete the top view face of the solid. So two isometric lines, they have been drawn, one of which is parallel to z-axis, another one it is parallel to x-axis, and both of these isometric lines or the edges, they happen to be having the length equal to 36 millimeter. So this is the top face of the solid. Now once we have drawn the top face, we are going to complete the bottom face. So another three isometric edges, they have been drawn parallel to x-axis, y-axis and z-axis, so that this base of the solid can be completed over here. Now we have obtained the front face, we have obtained the left hand side face, and we have been able to obtain the top face of this solid. Now let us start with the construction of the isometric projections of the solid. So as we had discussed, there is a ring over here at the base which is at a height of 12 millimeter. So I am going to draw this bottom ring over here. So this bottom ring, it is having the length equal to 36 millimeter and the height, it is equal to 12 millimeter. So let me draw this bottom ring. So once I draw this bottom ring at a height of 12 millimeter from the base of the solid, so I have been able to obtain this part of the front view. So this part of the front view has been obtained, and now we have seen that this is a face which is a continuous portion over here. So it means that this vertical web over here, so this is going to be measuring 12 millimeter. So you leave 12 millimeter from this end and 12 millimeter from this end. So automatically 12 millimeter web on the front face, it can be obtained. Similarly over here, this is my top face over here. This is my top face. In the top face, I am going to see a T-shaped projection over here, so that this is the horizontal component of this vertical web. So this is the vertical web over here, and this is the horizontal component of the central web over here. So please see, now I am going to draw the top portion of this T-shaped web. This is a T-shaped web over here. So again the dimensions, they are 12 millimeter, 12 millimeter and 12 millimeter. So the length 12 millimeter, again length 12 millimeter, again the length 12 millimeter. So I have marked 12, 12 and 12 over here. The moment I mark these three distance along the length at a distance of 12 millimeter from each other, now I can draw these two projection lines. The moment I draw these two projection lines, now we can see this T-shaped surface from the top, this has been located. This is a T-shaped surface which is lying on the top surface of this particular solid. And once I project this down, so the vertical central web will be located over here. The vertical central web has been located as I move down at a height of 24 millimeter from the top, because the bottom web was constructed with a height of 12 millimeter. So as I am going to move from this point and this point towards the top surface of this first web, so this distance will automatically be equal to 24, and I can see that this distance happens to be 24 millimeter in the front view. So please check, I have been able to draw or evaluate this front T face of this vertical web over here, right? So this is the T face of the vertical web which has been obtained in the front view. This is my front view face. Now I need to draw these slanted webs over there on either side of this vertical web, on either side, left side and right side of this vertical web. So what I am going to do, this is my corner point over here and this is my corner point over here, which is lying at this junction. So from this point, that is here, to this point, that is here. So from here to here, I am going to draw an inclined surface. So please check, I have been able to draw this inclined faced web over here. So this is the inclined rectangular faced web which I have been able to locate on the left hand side of this vertical web. This is my vertical web. On the left hand side of this vertical web, I have got this slant face web, and this slant face web is visible to me from the left hand side view. Similarly, there is one web on this side, slant faced or inclined. There is another inclined web which is lying on the right hand side also. So what I can do, I can join this edge over here. Now deliberately I did not join these two edges. Why? Because this vertical web, it has already covered this portion of the slant web which is going to appear over here. So since we have already discussed that in isometric projections, we are not going to use dotted lines over there. So towards the end of this construction, we will be joining these 2 points with a lighter construction line, that is a thinner construction line, just to show that this is also a rectangular inclined edge which is lying on the right hand side. But a portion of this inclined rectangular web has been covered by this T-shaped web over here. Okay, now all the edges of the solid, they have been obtained. Now I am going to join the edges which are visible to the observer over here. Now please check, from the front view, we are able to see this portion. So this is the flat web corresponding to this T. This is the flat web corresponding to the T which appears in the front face. So this is the T, inverted T, which appears on the front end side. Similarly, from the side, we have got this edge is dark and this edge is dark. So we can see this edge is dark, this edge is dark and this edge is also dark. And then you have got this edge dark, and then this is my inclined web which I am able to see from the left hand side. And from the top, again another T. Please check, from the top another T-shaped surface will be visible to me at the top surface of this particular component. This is the top surface of this particular component. So this T will be visible to me on the top face. So this is my T-shaped surface which is projected on the top face. This is inverted T-shaped surface which is projected in the front face. So we can see this T-shaped surface on the top view, and this inverted T-shaped surface in the front view has been obtained. And this is one slant edge and this is another slant edge. And what I have done, you see, with this very minute light construction line, I have joined this point with this point. Otherwise this has not got any significance. This is only to see that this is also a rectangular surface. We have drawn it, but this portion of this rectangular web has been covered by this vertical web which we have seen in the front as well as in the top view. So this is a full length web which is lying at the center of this solid. So this surface of this web, it is the horizontal shape. This surface of this web, it is having the vertical face. So I told you that this is at a full height and this is with a full width over there. So this is the construction of the isometric projections of the solid, wherein the orthographic projections or the orthographic views of the solid, they were made available to us. So this is all for today. So we are going to continue with further discussion regarding few more cases on the isometric projections of the solids in the coming lectures. So thank you very much. Thanks a lot.